Hi, welcome back. I'm Mr. Peck here. Today we are going to learn about two-dimensional collisions. Here's the questions. A 800-gram ball at 30 cm per second collides obliquely with a 500-gram ball moving at 50 cm per second in opposite direction. After the collision, the velocity of the 800-gram ball is 15 cm per second at 30 degrees to its initial direction. What is the velocity of the 500-gram ball? Okay, so let us highlight the information. We have the mass of the first ball, the 800-gram we denote as 1. And we have also the initial velocity collides obliquely. The word oblique, collides oblique. Oblique collision means two-dimension collision. Okay, two-dimension collision. But if the collision is head-on collision it is a one-dimensional collision. Okay, one-dimensional collision. So the word oblique means two dimension. We also have the mass of the second ball. Okay, denote as the 500-gram denote as 2, and the initial velocity for the second ball in opposite direction is very important. Opposite direction means you need to put negative sign to velocity. After the collision, the velocity of the 800-gram ball is 15 cm per second. So after collision, we have the final velocity and also the direction 30 degree. What is the velocity of the 500-gram ball? So we want to find the final velocity of the second ball. Okay, so for velocity is a vector. For vector, you need to give two things. You need to find the magnitude, you need to find the direction. For vector, you must give magnitude and direction both. Okay, if without direction, you lose 1 marks. Right? Good. Now let us continue. So I have illustrate the situation here. The ball 1, all the masses given. Ball 1, ball 2, the masses I changed to kilogram, from gram change to kilogram, divided by 1000. And the velocity also from cm per second, I changed to meter per second. And the important thing, just now he said the 500-gram ball is moving in opposite direction. So when opposite direction, the initial velocity of the ball 2, you need to put negative sign. Opposite direction means to the left. You must put a negative sign. Okay. For the ball 1 is moving to the right, so it's positive. Okay. After the collision, given the final velocity and also the direction, so I have written down here, after collide, the ball 1 has the final velocity 0.15 meter per second and 30 degree to this initial direction. So this is the direction. So find the velocity of ball 2. So I don't know what happened to ball 2. Let's find out. Okay. So how to do these questions? We always, for collision, we always use conservation of linear momentum. Principle of conservation of linear momentum. Because no matter it's elastic or inelastic collision, the momentum is always conserved. Okay. So we can use the conservation of momentum. So since here has degree, 30 degree, and also he says it's oblique collision, means this is two-dimension collision. And for vector, when you have two dimension, you need to break into x and y components. Alright? You need to break into x and y component. So I separate into two parts, x component and y component. So conservation of momentum applies. So, but you don't write like that, yeah? M1 U1, M2 U2, don't write like that. You must include the components. This one is x component, so this U1x, U2x, V1x, V2x. Same thing to the y component, V1y, U2y, V1y, V2y. Just add on the components. So let us look at x component. All right, for x component. So let's look. This is before collision and this is after collision. Okay. So before collision, we have the the velocity is x component. Velocity is x component, so we can write it down. all the information. All right, let's continue. So mass 1, we have the 0.8 u1x. This one is in x component, 0.3 plus mass 2. Mass 2 is 0.5, and u2x. U2x is to the left. It's going to the left, so it's negative because it said opposite direction. You must remember, must put a negative sign. Don't forget your negative sign. Many students forget the negative sign and they got it wrong. All right. This is before collision. Equals to after collision. We have the ball 1 0.8, and for S component, okay. So you see, this one can be resolved into two components. Can be resolved into two components. The we have this one is 0.15 cos 30, and this one is 0.15 sine 30. Okay. So now let us continue. So we have for S component V1x 0.15. Just write it down. 0.15 cos 30. Okay. And then plus the mass 2 is we have 0.5, but we don't have the V2x, so we want to find V2x. Okay. So calculate. I got V2x equal to, after calculation, I got V2x equal to negative 0.2278. Put 4 decimal place so that more accurate. Okay. Put 4 decimal place so that more accurate. Now, this one is negative. Negative means it's going to the left. Okay, negative going to the left. Now, check the y component. Check the y component. So, before collision, let's look before collision. Is there any y component for velocity? No, all this velocity is only in x component. So, no y component. The velocity in y component is 0. So, we can say momentum in y component is what? Is 0. Is 0. Because no y component. U1y, U2y, all 0. So multiply, also get 0. Okay, let's continue. So what happened after collision? After collision, we have V1y, 0.15 sine 30. Going up. So it's going up, so it's positive. Yeah, it's going up, so it's positive. So let us write it down. We have okay, the mass ball 1 is 0.18. 0.8. Okay, so it's 0.8. And then we 0 is going up. Yeah, the y component is going up, so positive 0.15 sine 30. 0.15 sine 30. And plus the mass 2 is 0.5 kilogram. 0.5. We want to find V2y. So we can find V2y. So we got the answer. V2y is equal to negative, going down, 0.12 meter per second. Okay, so good. So now we have the final velocity for ball 2, the x component and y component. So that means now we know that for x component is going to the left because negative, and for the y component is negative also, so it's going down. Y component is negative, going down. So that means the ball 2 is the going to the left, going downwards. Okay, going left, going downwards. So we have the this is the V2x, which is negative, and this is V2y, which is also negative. So this is the resultant. This is the resultant. This is the V2 which we want to find, and we need to find this angle theta below negative x-axis. Okay, so how to find the V2? Very simple, the Pythagoras theorem. Okay, so let us find it out. V2, the magnitude. Modulus means magnitude. We square and square, square plus square, the v2x square plus v2y square. Okay, substitute all the information. We have negative 0.2278 square plus the v2y negative 0.12 square. So after more square root, we got 0.26 meter per second. That is the velocity 2. We got the magnitude. Now we want to find the direction. Direction, use tangent theta. Tangent theta equal to tangent theta is v2y over v2x. Okay. Modulus, we want to remove the negative sign. So the v2y is negative 0.12, negative v2x is negative 0.2278. So the negative is removed because got modulus. So inverse tangent, we got 27.78 degree below negative x axis. That's the direction of velocity 2. Okay, that's theta. Below the negative x axis. Okay, so this is velocity 2. We already got the magnitude and direction. All right, so that's it for the two-dimensional collision. We must always do x and y component resolve into components, and don't forget, if you have negative sign moving in opposite direction, you must put negative, and then we resolve the vector cos theta sin theta, and then we combine again, find the magnitude, use the Pythagoras theorem, and find the direction using tangent theta. So that's it for the two-dimensional collision. I hope you enjoyed the video. Please subscribe and like. Bye.